Hello and welcome to Intermediate Algebra, Unit 6, Lesson 5. This is part 1 of 2 videos in this lesson. In this part we will look at solving by factoring. In the second part we're looking at solving application problems that require factoring. So we did all of our factoring techniques and learned how to factor. Now we're going to start looking at how to use factoring when you have something you can factor within an equation. Most typically you'll have to make it so that equation has one side that's 0. That's what we're going to see. So after this we should be able to solve quadratic equations. Now up until this point we've worked with quadratic expressions. They don't have an equal sign involved, it's just a standalone expression. But we're going to work with solving quadratic equations by factoring and using the zero factor property. So, what is a quadratic equation? Well, you've seen this ax squared plus bx plus c before, and we called it a quadratic expression. It's also called a second degree expression. But once we put an equals sign there, especially when we put equals 0 for our situation, we now have a quadratic equation where some quadratic expression is equal to 0. A, B, and C are real numbers and they're the coefficients of our variables. In case of C it's the constant term. B can be 0 and C can be 0 and you'd still have a quadratic equation, but A cannot be 0 because if A were 0 you wouldn't have this term at all because 0 times anything is 0. But you would have bx plus c, which is not quadratic, it's linear, that's a line. So we are looking at quadratic equations here, and when you're in the form ax squared plus bx plus c equals 0, that's called the standard form of the quadratic equation, and that is the form that we will use to solve these equations. So in order to solve these equations, it's actually a fairly simple technique, but you have to have thought about what it means to have 0 as the product of two quantities. So it turns out anytime you multiply anything times 0, you get 0. So if you're told two things multiplied together come out with a result of 0, it means one of them was 0. So if we were to solve this equation, ax equals 0, say a is 3, say 3x equals 0, we divide both sides by 3, or in this case by a, we get x equals 0. So that's always going to be true, no matter what number a is. In order to get 0, I must have multiplied it by 0. So what if instead of a constant or a coefficient, we have two variables multiplied together? Or we're going to see two expressions with variables multiplied together. So I'm told x times y equals 0. What I do know is that either x or y, or even both of them in this case, are 0. But at least one of them must be 0 for this to be true, because the only way you get 0 when you multiply two things together is if one of them, or at least one of them, was 0. So let's look at an expression in factored form that's put into an equation now. So we factored one side and we got x plus 2 in parentheses times x minus 3 equals 0. We need to solve this. To solve means to find all the values of the variable that will make this equation true. In other words, all the values we can replace x with that will result in 0 when we multiply these two factors together. So basically what it means is either this x plus 2 was equal to 0, the first factor was 0, or the second factor was 0. So I write equations and solve them to find out under what conditions will x plus 2 equal 0, and under what conditions on x will x minus 3 equal 0. Those are very simple equations to solve. And that's how all of this is going to go when you're told solve by factoring. The big important step is to make sure you rearrange things so one side of the equation is 0. So our solutions are x equals -2 or x equals +3, because those two, that that's the solution to each of those equations. And if I put -2 in for x, I'll get 0 in this from this first set of parentheses, and I'll get -5. But it doesn't really matter because I'm going to multiply it by 0, so I'm going to get 0. If I put +3 in, I get 3 plus 2 is 5 in the first set, but I get 5 times 3 minus 3 is 0. So that also makes the left side of my equation 0, which will make the statement true. So here are the steps. First, you need to put the quadratic equation into standard form. First of all, make sure you're only doing this when you have an equation. This isn't you're told to factor something. This is you're told to solve the equation. And solve by factoring maybe, but when you're just given an expression, there's no equal sign in the original problem. You don't use this. So we're going to put the quadratic equation in standard form. It means we have to make one side 0 by adding or subtracting terms from both sides such that one side has all of its terms that aren't 0 canceled out. So then we factor the quadratic, and then we take each factor and write an equation with each individual factor equal to 0 and solve. In this case, it'll be both equations. But this technique actually works for higher degree polynomials too. You'll see later on in your coursework that you can have a cubic or a fourth degree, and if you have 4 factors multiplied together, you use this same process where you either given or find all your factors, and then for each factor, in that case it would be 4 of them, you're going to write an equation for each factor equal to 0 and solve all 4 equations. For us right now, we're just dealing with a second degree polynomial, so we're only at most going to have 2 equations to solve. At times we may actually have 1, because if your factoring comes out to be, oh, it's x minus 3 whole thing squared, then just x minus 3 equals 0. So let's move on, and here's an example. So the first thing I check, is this in standard form? Yes, one side is 0, so I can use the 0 factor property. And that's the only time you can use the 0 factor property, is if one side is 0. So I factor the x squared minus 3x minus 28, and I get x minus 7 times x plus 4. Now I write an equation, each factor, so the first one is x minus 7 equals 0, and then the second equation I write is for x plus 4 equals 0. Now this has kind of become my problem. I can forget about all the fancy x squareds and everything. I just look at these two things and solve each of them. I add 7 to both sides, and that gives x equals 7. I subtract 4 from both sides in this other factor, and I get x equals -4. So there are 2 solutions, and they are 7 and -4. So here's another example where we solve by factoring. Something is different about this problem as it's stated. Take a look at it. So remember, the first thing you have to do is make one side 0. Some of you may be tempted to say, oh look, I can take the y out and get 7 plus 3y. No, you need to move this -2 first, and then I would suggest you put everything in order. So I add 2 to both sides, and when I add 2 to the right side, that becomes 0, and it adds a 2 to the left side. Now the y squared is in the middle, so I just rearrange these, and you can do that as long as you keep the signs of the terms with them. In this case, they're all positive, so it wouldn't matter anyway. So I get 3y squared plus 7y plus 2 equals 0. And I'm going to factor this. Now this is one of those with a coefficient that's not 1 in front of the squared term, so you could do guess and check, or you could factor by grouping. If you factor by grouping, you take the 3 times the 2 and you get a 6. You factor that and find out what pair of factors adds up to 7. It's 6 and 1. So I broke this middle term up into 6y plus 1y. We don't write the 1. And now I'm going to factor by grouping because I now have 4 terms. So in the first pair, I'd have 3y squared plus 6y, and a common factor of 3y would come out. And then the second pair would be y plus 2, and there is no common factor, so you might find it helpful to write a 1 right there. I didn't do it because technically we really kind of don't write that, but you may need to do that in order to get to this part of the factoring correctly. A lot of students just say, oh look, that's just 3y times y plus 2. No, it isn't. It's 3y plus 1 times y plus 2. So I get to that part. I get the y plus 2 times 3y plus 1. Now I have to write each factor in its own equation equal to 0. So y plus 2 equals 0 and 3y plus 1 equals 0. Now I solve each equation. Subtract 2 from both sides for the y plus 2 equals 0, and you get y equals negative 2. And then in the other factor, you subtract 1 from both sides. That'll give you 3y equals negative 1. And then you're going to have to divide by 3 to get y by itself. So your two answers are y equals negative 2 and y equals negative 1/3. So here's another one, and students tend to find these tricky. First I look, and yes, one side is 0. Don't have to rearrange anything as far as putting things on the other side. I have squared first and not squared. But when we're missing that constant term, there's no constant term at the end. Both of our terms have the variable in it. Students get confused. You know how to factor this. It has two terms, and like all factoring, the first thing you do is look for a common factor. Actually look for the greatest common factor. So 5 and 10 have a common factor of 5. I have a b squared, I have a b. B to the first is the lowest power that occurs, so I can take a b to the first out, or just a b, you might be thinking. So I take a 5, I undistribute a 5b, and in order to get back my original problem, I would have to multiply 5b times b minus 2. So here is my factored form. So I write an equation where 5b equals 0, and I write an equation where b minus 2 equals 0. In the first equation, to get b alone, I divide both sides by 5, and b is 0. Or you could say, oh, 5 is not 0, so b must have been 0 by the zero factor property. In the second equation, b minus 2 equals 0, you add 2 to both sides and get b equals 2. Okay, so this is a third example solved by factoring. One side is already 0. I factor this and I get x minus 3 times x minus 3, or you could say x minus 3 squared. So you really only have one factor. It occurs twice, which becomes important later, but for now that means there's really only one equation to solve. Just to put everything in the same form, I wrote down each factor equal to 0, and of course I get the same answer, x is 3, because the factors are the same. Okay, so here's some for you to try. Remember, you're going to make one side 0 first, look for a common factor, and then complete your factoring. Shut the video down in a moment and check your answers on the next slide. When you come back, we'll go over them. Okay, so go to work. All right, you're back, and I'm going to assume that means you tried these. So let's look at the solutions. The first thing you had to do in the first one was move the 6x to the left side so that you'd have 0 on the right. You don't always have to put the 0 on the right. You could have moved the x squared plus 8 by subtracting them, but it's nice to have positive leading coefficients when you factor. So we moved the 6x. And when I did that, it gave me a minus 6x on the side. I put it in order, and then I factored to x minus 4 times x minus 2, and I got x is 4 and x is 2. So the answer is x equals 4 or 2. The work would be the factoring and the rearranging. So in this second problem, again, I had to rearrange. I had to subtract 3 from both sides and then rearrange to put the y squared term in the front. 2y squared plus 5y minus 3 equals 0. That factored to 2y minus 1 times y plus 3. That gave me y is 1/2 or negative 3. And if I put either of these answers into the original problem, I will get 0. The next one was one of those that had two terms, problem 3, and it was in order, and you see you had a common factor of 8b, and your answer is 0 and 2. The next one, I don't remember if they were in order. You had to move that negative 10x by adding 10x to both sides. And you see that you get x plus 5 times x plus 5, or x plus 5 squared, because this is the binomial squared. 25 has a square root of 5, x squared is a square root of x. This is 5 times x times 2 in the middle, so it fit that pattern. So I really only have one equation to solve. X plus 5, it occurs twice. That becomes important later in your studies. But x equals negative 5 is the solution. And for the last one, I had the difference of two squares. I had 4x squared minus 9. So that's 2x plus 3 times 2x minus 3 is the factoring. And if I solve 2x plus 3, I get x equals negative 3 halves. If I solve 2x minus 3 equals 0, I get x equals 3 halves. Alright, well, I hope that was helpful, and now you can go and try some other problems and do your homework and email me your questions. Thank you.